Okay, here we are in week 6, and we are still on the topic of inferencing, but we will cover two topics really in this class, ending one and starting another. So in the first segment of this week's class, we will make inferences about population variability. You may have noticed in the preceding 2 weeks when we were making inferences, whether it was hypothesis testing or interval estimation, we were making inferences about the population mean. There are many different properties of a population about which we might want to make inferences, and in the last 2 weeks we saw how to make inferences about the population mean, because the mean is a good indicator of what's happening on average within the population. So here in this first part of this week's class, we will see how to make inferences about population variability. So variability is dispersion around the mean, around the middle, and we want to be able to make inferences about that. Typically, variability refers to lack of consistency or lack of quality in business processes. So we want to be able to draw inferences about it, and soon enough I'll show you some examples of it. The second topic that we will start this week, we probably won't finish it, we will certainly continue with it the following week, and that's simple linear regression. Out of all the techniques that you're learning in this course, this technique or tool, if you will, regression, is probably the one that you'll run into most frequently in subsequent classes. So it's a good idea to get mastery of this particular topic. And you will also find that this one topic of linear regression brings together a lot of the other inferencing topics like hypothesis testing and interval estimation that we have discussed so far. So shortly enough, I will show you examples of these two topics. But first, let me look at the syllabus here. We are in week 6. So this is section 11.1 and 11.2, and that covers topics about population inferences about population variances. And we will also start linear regression. The linear regression actually starts in chapter 14. Chapter 14 is devoted to simple linear regression. So you might want to read up on some of these sections here as well. There may be section 14.1, 14.2, and just some initial sections about linear regression. Okay, so we will see how far we get into linear regression. It depends on how much time we spend or have to spend on inferences about population variances. That's why I didn't put the chapter numbers here explicitly, but if you want to read up ahead, then perhaps section 14.1 and 14.2 might be appropriate sections to read. Okay, let's get back to some examples over here to give you a sense of what it means to make inferences about population variances. So let's say that a bulb manufacturer puts out LED bulbs, and these are expensive bulbs, and that they are supposed to last on an average 40,000 hours. So one of the kinds of inferencing that we might do using the techniques that we have learned in the previous 2 weeks is to test whether on average the bulbs that this manufacturer is producing, they last on average at least 40,000 hours. So that type of inferencing we know how to do. In this week's class, what we will test is the variability of the lifetime of these bulbs. Some bulbs will of course last more than 40,000 hours. Some bulbs will of course last less than 40,000 hours. And it's not nice if one bulb lasts 50,000 hours, another one lasts 30,000 hours. So they should not be. So even though on average the bulbs last 40,000 hours, you also want to make sure that there is not a whole lot of variability in their lifetimes. So the only way to test this is to look at a sample of bulbs, burn them out, and see what is the variation in the lifetime of the bulbs that you tested. And from that, draw some conclusions about the variability of the population of bulbs that you're producing. So you're drawing conclusions about the variance of bulb lifetimes rather than the average. A second example is also from a manufacturing setting. You have a specialty company that is producing brake pads for aircraft, and these parts have to be manufactured to very close tolerances. So you don't want the brake pad thickness to vary too much. You know that Manufacturing processes are not perfect. Some brake pads would be thinner, some brake pads would be thicker, but they should not vary a whole lot. So based on sampling of brake pads during the manufacturing process, you want to draw conclusions about the entire population of brake pads that this company is producing. So here again, you're trying to draw conclusions about the variance of the thickness of the brake pad rather than the average thickness. How does one go about doing that? So these first two examples, and we'll probably be spending most of our time this week on this inferencing about population variances. So one type of inferencing will be confidence intervals, the other type of inferencing will be hypothesis testing, and the parameter about which you're doing inferencing will be the population variance. So that's the first topic, and probably most of our time will go on that. Depending on how much time we have left over, we will start this next topic, which is the one I said you're likely to run into most in subsequent courses, and that's regression. In regression, and we'll start off with the simplest type of regression, which is linear regression and simple linear regression. Essentially, what you're trying to do is you're trying to describe the relationship between two variables, in this case, sales and advertising, in the form of an equation. Okay, rather than saying we already know what correlation means and what scattergrams mean, but here we are trying to express the relationship between two variables in the form of an equation using sample data. Okay, so basically we are trying to estimate these two numbers. What's the intercept and what's the slope of the straight line using sample data. And the reason behind doing this is once you have this equation, if you feel that this equation represents the relationship between sales and advertising reasonably well, then you can make predictions. If you can say that, okay, if I spend $10 million in advertising, how much would I expect sales to be? You would just plug in the value for advertising, and this equation will give you a predicted value of sales. So it would give you some sense of what you would expect your sales to be. So this is what is involved in linear regression, and we will see not just some of the concepts behind linear regression, why this equation is not quite perfect, what are the uncertainties involved in estimating this equation, and how does one deal with that uncertainty. So the bulk of this week's class will be on this first topic, that is making inferences about population variability, and then we will start the topic of linear regression depending on how much time is left over.